It's your boy, another video. A lot of you man just said that you didn't like the last video. I heard you. Okay, I heard you. All 8 of you. Alright? I know I haven't got many subscribers, but allow me, alright? So this video is going to be Avogadro's constant 2. The previous video, Avogadro's constant 1, we learned about what Avogadro's constant is, the different formulas there, and mainly about what that topic was about, to do with what you use Avogadro's constant for, what you can find out using Avogadro's constant, essentially using the moles of atoms from that compound. First, we have to work out the moles of atoms, which is just basing it off how many atoms you have in that compound, and that's how many moles of atoms you have in that compound. And then you use that moles of atoms, multiplying that by Avogadro's constant, 6.022 times 10 to the power of 23, and then you'd find the number of atoms in 1 mole of that compound. If you briefly remember in that video, basically it just explained a little bit about the equations for working out moles. And there were 2 equations, hopefully I mentioned both of them. But if you know anything from GCSE, one is moles is equal to mass over the MR, or moles can be equal to the concentration times by the volume. We're going to use those 2 equations and then bring that back and use the information from the last video, because it's very unlikely that the exam will give you, or an AS, they'll give you a question where it's just work out the number of atoms in this compound. It's very unlikely. It's a very easy question. So the 1 mark will most likely be, this is the number of, this is the MR, not MR, this is the volume, this is the concentration, or they're giving you, either they want you to work out the concentration or the volume and then use that to find the moles, or they'll give you the mass of the compound to expect you to go into the periodic table and find the MR and then substitute that to find the moles. Once you get the moles, you can work out, once you have the moles of your compound, multiply that by Avogadro's constant, and you can use that to work out your number of atoms in 1 mole of that compound. So we're going to go through one example right now. Hopefully, if you can see it. If you can't, just adjust this. There we go. I'm just doing this one here. Hopefully you can see it. So the LO's learning objective from last time is the same, but calculate the number of atoms from a given mass of a chemical. So here we have an example. So they want you to work out the number of atoms in 48 grams of magnesium. If you go to the periodic table, magnesium here is got an AR, or atomic mass, of 24.3. Sorry, a relative atomic mass of 24.3. Atomic mass would just be 12. Yeah, so the relative atomic mass will be 24.3 here. But usually you can get away with 24. When you go into A level, you have to use the actual decimal places, especially if they're closer to 0.5 or and not closer to a whole number, or an integer, I should say. But in this case, you can get away with using just 24 in AS. So you have, I've left it as 24 here. So if we want to work out the moles, we want to find the number of atoms. In order to do that, number of atoms, if you don't remember to work out the Avogadro's constant, or if you want to work out the number of atoms in 1 mole of a compound, you need Avogadro's constant, and you need to multiply that by the moles, essentially, like last video. So, or 2 videos ago. I think it was 2 videos ago. But anyway, but first we need to work out the moles. Moles is equal to the mass over the MR. You have here, so we have a mass of 48 and our MR is 24. 48 over 24, you can do that in your head, and that equals 2. Then you multiply 2 by 6.02 times 10 to the power of 23. Can be 6.022. They usually give you a number. They usually give you the number in the exam, but in A level it's 6.022 times 10 to the power of 23. But I don't know about AS. I think you can get away with 6.02 times 10 to the power of 23. When in this case my answer was 1.204 times 10 to the power of 24 atoms. So now we have our, and that's your answer there, 1.204 times 10 to the power of 24. To be honest, this answer is technically wrong because although it's the right answer, the question gave us 2 significant figures, and I wrote my answer in 4 significant figures. So in reality, it should take out the 04 at the end. It should be just 1.2 times 10 to the power of 24 atoms. Your value, when you're making an answer, when you're getting your answer, make sure not to fall into the trap like I did with giving your answer to the full amount. Although it's technically right, your answer is never more significant than your least amount of significant figures in your question. So if you're giving you 2 significant figures, your answer technically isn't more significant than your least amount of significant figures. And in this case, we only have 2 significant figures in both occasions. So use 2 significant figures. Alright. Let's go for a second example. In this second example, we have to calculate the number of atoms in 28 grams of lithium. 28 grams, so we have the mass, we have to work out the moles, so we have the mass, and then we need to go to the periodic table to find the basically the relative atomic mass. Always keep getting relative atomic mass. So lithium here is in group 1, top of group 1, well, apart from hydrogen. It's got 6.9. It's got a relative atomic mass of 6.9, but you can just round it up to 7. In AS, they won't get onto you if you round up to 7. Maybe if you go higher up, then it might get onto you. But 7, you can use a relative atomic mass of just 7. 28 divided by 7, simple. You should know. You can do that in your head. That'll be equal to 4. And 4 times by 6.02 times 10 to the power of 23 equals 2.408 times 10 to the power of 24 atoms. Again, I made this a really long time ago, so it should just be 2 significant figures because it's got 28 grams is the lowest, it's the only value that you get, and it's 2 significant figures. So it should be 2.4 times 10 to the power of 24 atoms. Alright, I've got one last example here. Got work out the number of atoms in 56 grams of calcium oxide. I'll give you, I shouldn't really give you time. Pause the video now if you want to answer the question. 56 grams of calcium oxide. And then I'll just remove this like really poor attempt of trying to cover it up. Yeah. Alright, so I'm going to assume that you pause the video. If you haven't, feel bad. So first of all, we need to work out the moles. Moles is equal to mass over the MR. The MR is calcium plus oxygen. So it should be, if you go to the periodic table, relative atomic mass of calcium is 40. 40.1, but you can just say 40. And oxygen here is 16. So you use 40 plus 16 equals 56. 56 over 56 is 1. So you have 1 times by 6.02 times 10 to the power of 23. You only have to write 1. But that will get you back to 6.02 times 10 to the power of 23 atoms. Yeah, and that's it. Hopefully you got the right answer. Hopefully you found this useful. That's it.